In this video, we're going to be looking at measures of variation and shape. So what is variation? Well, that measures the spread or dispersion or dispersion of the values. Okay, so that's what the variation means. It means kind of how spread out are your values. One way we can do this is with the range. So the range is a measure of variation. And this is just the difference between the smallest and highest values in the data set. So in particular, the range is equal to x largest minus x smallest, where x just represents these variables just represent your data points. So the largest data point minus the smallest data point. All right. Well, we have a few other ways to measure dispersion or variation. And so let's look at those a little bit more in depth. So besides measuring the range, perhaps you'd like to measure the scatter around the mean. And by that, we mean that suppose we have a data set that looks like this, and then a data set that looks like this. So maybe we have a numerical variable along the x-axis, and then the frequency, so how often this particular variable occurs, along the y-axis, and our data, we have two different data sets. One looks like this, and the other one looks like that. Well, this we say has large variance relative to this kind of a figure where we say it has small variance. And here's one way to think about that. We think about the mean probably being here in the middle, and a lot of these values, there's not a whole lot of values around that mean, but a lot of them are kind of spread out really far away from the mean. So we say that data set has large variance, as in the data is spread out more. Here, if we have the mean here, the data set's clumped together closer in towards the mean, and so we say it has small variance, as in it's all the data is clumped together around the same region. Okay, so there's two values that we want to calculate that are related to this topic. And the first one we're going to look at is called the sample variance. And we use the notation s squared for this. And what is s squared? It is the summation from I equals 1 to n of the difference between x sub I, so one of the variables, one of the data points, minus the mean, all divided by n minus 1. Okay? And where x bar is the average or the mean of the data set, n is the number of points in the data set, and x sub I is just the ith variable in the data set. Shouldn't really say it like that. I should say the ith value in the data set, not the variable. All right. And so this is our definition of the variance. It is s squared, which I left off a square. Which is, so make sure you go back and you add that in. It is the summation from I equals 1 to n of the square of the differences between a single point, each individual point, and the mean. And then all of that divided by n minus 1. All right. And now, related to that, we just defined s squared. So related to that, we have the sample standard deviation. And that is just the square root of s squared. So we just label that with an s, which of course is this formula. It is the square root of the sum from I equals 1 to n of the squares of all of these differences. Of course, that divided by n minus 1. All right, and that's our definition for the variance and now the standard deviation. And one thing I'd like to point out is that most of the data will lie within the interval x bar minus s to x bar plus s. So essentially we find an interval where the midpoint is our mean, and we look at the interval from the mean minus the standard deviation to the mean plus the standard deviation, and most of the data lies in that interval. In other words, most of the data lies within one standard deviation of the mean. So, and again, what is this telling us? This tells us essentially how spread out the data is. The S does. The standard deviation does. It gives us a measure of that, a measure of how spread out the data is. Okay, let's do a quick example related to finding the standard deviation. All right. So let's suppose our data for n equal to 7 points is, so we just have 7 data points, and those values are 12, 7, 4, 9, 0, 7, and 3. Well, first thing you want to do if we're trying to find the standard deviation is to find the variance, but the variance is just this thing inside the square root here, and to find that we need to know what the mean is. So we need to find the mean first. So x bar is equal to, and then we just add up all of our values, 12 plus 7 plus 4 plus 9 plus 0 plus 7 plus 3, all divided by 7. All right, let's see here. It's 19 plus 4 is 23, plus 9 is 32, plus 10 more is 42. So this is 6. So we get 6 is our mean. And now to find s squared, this is the sum from I equals 1 to n of x sub I minus x bar all squared divided by n minus 1. And so what do we get here? This is 12 minus 6 squared plus 7 minus 6 squared plus 4 minus 6 squared plus 9 minus 6 squared plus 0 minus 6 squared plus 7 minus 6 squared plus 3 minus 6 squared, all divided by n minus 1. N was 7, so n minus 1 is 6. And what is that? Let's see. This would be 12 minus 6 is 6. So 6 squared is 36 plus 1 plus 4 plus 9 plus 36 plus 1 plus 3. 9. 3 squared plus 9. All of that divided by 6. This all added up together should be 96. And so that is 16. And again, this is our variance, which is s squared. So our standard deviation is s equal to the square root of s squared, which is the square root of 16, which is 4. And that's where we will end this video.